fusion energy is a form of energy that is produced through the process of nuclear fusion, which involves combining atomic nuclei to form heavier nuclei. This process releases a large amount of energy in the form of light and heat, similar to the process that powers the sun. One of the biggest advantages of fusion energy is that it is a clean form of energy that does not produce greenhouse gases or other pollutants, in contrast to fossil fuels, which emit carbon dioxide and other harmful substances when burned. Fusion energy produces only helium, which is a non-toxic gas. This makes fusion energy a promising alternative to traditional energy sources, as it could potentially help to reduce greenhouse gas emissions and mitigate the effects of climate change. Another advantage of fusion energy is that it has the potential to be a virtually limitless source of energy. Fusion reactions release significantly more energy than other forms of nuclear energy, such as fission, and there is an abundant supply of fusion fuel available in the form of hydrogen, which can be obtained from seawater. This means that fusion energy has the potential to meet the world's energy needs for thousands of years, making it a highly sustainable and desirable energy source. However, there are significant challenges associated with developing fusion energy, such as creating the conditions necessary for nuclear fusion to occur and the cost of building and operating fusion reactors. While fusion energy holds great promise as a source of clean and sustainable energy, like any technology, it is also prone to abuse. One potential concern is the possibility of using fusion energy to produce weapons. The same nuclear fusion process that powers the sun and stars can also be used to create nuclear weapons, which are extremely powerful and destructive. It is essential to ensure that the technology and knowledge needed to produce fusion energy are not misused for military purposes or to proliferate weapons of mass destruction. Another potential concern is the possibility of accidents or mishandling of the materials involved in the fusion process. Fusion reactors use extremely high temperatures and pressures to contain and control the plasma needed for fusion. If something goes wrong, such as a breach in the containment system or a malfunction in the reactor, there is a risk of radiation release and other hazardous consequences. It is important to ensure that appropriate safety measures and protocols are in place to minimize the risk of accidents and to respond quickly in case of an emergency. Finally, there is the potential for fusion energy to exacerbate existing social and economic inequalities. Developing fusion energy requires significant investment in research and development, as well as the construction and operation of expensive infrastructure. This could lead to a concentration of power and resources in the hands of a few, with the benefits of fusion energy disproportionately accruing to certain regions or groups. It is important to consider the potential social and economic impacts of fusion energy development and to work towards equitable distribution of its benefits. While there are significant challenges and potential risks associated with fusion energy, the potential benefits make it an area of ongoing research and development. As such, researchers must work to ensure that fusion energy can be developed in a responsible and sustainable manner.